Hey, how are you doing, guys? Are you feeling good? I hope so. We're going to talk today about transformation geometry. Specifically, we're going to talk about rotation. When I ask you to rotate around something, you have to ask me some questions first. Like, in which direction I'm going to rotate? And how many degrees? So, to get these points, let's get started. The first question. Describe fully the single transformation that maps triangle P onto triangle Q. We want to do something to move this P onto Q. Someone would say we're going to translate it till here, then we're going to rotate it. No, it's not allowed to say that. Because he said here single transformation, just one thing. Transformation, we have 4 types. We have rotation, dilation, reflection, and translation. So which type are you going to use? Maybe you're going to say translation, that you're going to move it upward. Then you're going to rotate it. We said no, single only. Just one word. Okay, so translation doesn't work because the translation keeps the position of the shape. Okay, maybe it's going to be dilation. No, because the dilation is going to make difference in sizes. Maybe it's going to be bigger than the other or smaller than. So it's not allowed to say dilation. So maybe it's going to be reflection. Yes, reflection. Look. No. The reflection has to be the same position. It's horizontal. Here has to be horizontal but flipped. We don't have horizontal here. Or vertical and flipped shapes. So of course it's going to be the 4th one, which is rotation. So we rotate this shape to be here around a point, the center. Don't forget, there's a target. And this target is somewhere here. So where is it exactly? We're going to guess now. But firstly, we moved P to Q. So in which direction? Yes, great if you said anti-clockwise. So we're going to move in this direction. Great. Next, we're going to guess a point. Maybe it's going to be the center. Because when I ask you to describe fully the single transformation that maps triangle P onto triangle Q, you have to mention the center. You have to mention the transformation. You have to mention the degrees. You have to mention the direction too. Okay, let's guess. Yeah, suppose that point is the center. Now we're gonna check that the answer right or wrong. What we're gonna do, just join this center by a point here. Then join the center by the corresponding point or the corresponding vertex for this point, which is here exactly. So this corresponding to this, and this corresponding to this, and this point is corresponding to this. Great. So I'm going to draw another line. If you found the 2 lines are equal, so great. You got the center. But I think it's not right. The lines are not equal. So it's going to be wrong, of course. Let's try another one. I guess that the point is the origin point. Okay, 0, 0. Let's try the first line, the second line. Yes, great. The 2 lines are equal in this case. So it's not enough. Maybe we need more lines to check our answer. So I'm gonna join the center by another point and it's corresponding. Look. So the red line, and we have another red line, and we're gonna find the same length. Okay, so we got it. So we have a center, we have rotation, and we have anti-clockwise, and the last thing, which is the angle. How many degrees we have? Yes, great. We have 90 degrees because we have here what? Yes, great. If you said that we have 90 degrees here using the protractor or the set square, I think the set square is going to be easier to put the set square here and here. You're going to find it exactly 90 degrees, or the blue lines together or the red lines together to check that it's 90 degrees and it's anticlockwise about the center, which is 0, 0. So what you're going to say, rotation 90 degrees anticlockwise about 0, 0. Let's solve another question. Describe fully the single transformation that maps triangle P onto triangle Q. We want to move triangle P to Q. So what we're going to do? Yes, great. We're going to say where is the center and in which direction we have. So P to Q, yes. Of course, the center is somewhere here. So we're going to move around it from P to Q. So, great. Clockwise. Excellent. So this is the first thing. Now we're going to talk about the center now. Guess. Where's the center? I guess that's 0, 0, maybe. So draw two lines to check your answer. I drew here a line, another line. Of course, it's not right because we have different lengths. Okay, try another vertex or another center. 1, -1, maybe. We draw the first line. We draw the second line. You'll not find it right. Maybe it seems right, but when you measure it using the ruler, it's going to be wrong. If you think that it's right, so try another two vertices, corresponding vertices, to check your answer is right or wrong. If you found that two lines are equal, so you have the center, you got it. Okay, let's try another center. So 0, -1. Let's try. Draw the first line, draw the second line, use the same corresponding points. Don't forget, you cannot use this line and another line here. You cannot use these two vertices together. Okay, corresponding vertices only. Okay, we got it. So it's going to be right. Some students are using another way. They are saying from this center to this point, moving vertically and horizontally only. Look, 1, 2, 3. 1, 2. So again, 1, 2, 3. 1, 2, 3 and 2. And here, because it's rotated, we're going to start from the horizontal. 1, 2, 3. 1, 2. So you're going to find the same directions or the same units, number of units. So we got the answer. So it's 90 degrees, of course. Between them we have 90 degrees. Use the protractor or the set square to measure it. So we're going to say what? Rotation 90 degrees clockwise about 0 and -1. Next question. On the grid above, rotate shape R 90 degrees anticlockwise with center 0, 1. With center 0, 1. Okay, firstly, we're gonna say in which direction we have to move, to rotate. Yes, excellent. We're gonna move in this direction because it's anticlockwise. Then we're gonna guess where is the center. No, you don't need to guess. Look at this. He said 0, 1. So we're gonna cross 0, 1. Now we're gonna draw lines from the center to the first vertex. Then we're gonna draw it here again. The second vertex. We're gonna draw it back here. The third vertex. Then we're gonna draw it here. The fourth. We're gonna draw it here. But how can we draw it? The first one. We draw here a line to make the same distance here in this area. Somewhere here. But where is it exactly? So you need to use a set square in this case. Why? Because you cannot fit the 90 degrees exactly without using any tool. So I'm going to put here a set square on the line and the vertex exactly on the center or at the center. So now you're going to extend the line from the center beside this side. So it's going to be like this? No, because you extend the line more than you need. Look, the length here is what? So it's more than this one. So you need to draw it exactly the same length of this one. So we're going to draw it till here only. So we have here the first point. Now we're going to draw another line from the center to the other vertex, the second vertex. And now we're going to put the set square again to fit the direction. Now we're going to draw a line, and this line has to be equal to this line exactly, Now we're gonna join the center by the third vertex. Yes, this line, maybe it's not clear because it's exactly on y-axis. So we're gonna put the set square here to draw it again, and it's clear to draw it directly. How many units? 1, 2, 3, or count it or measure it using the ruler and draw it again here. It's gonna be like this. So we have here point, we have here another point, we have here another point. We need the fourth point, which is here. So we're gonna continue, draw another line, which is the purple, and we're gonna put the set square again to draw the fourth line to get the point. By putting the set square, you're gonna find the line is gonna be here, same length, and between them 90 degrees. So the red lines, we have between them exactly 90 degrees. The purple lines, we have between them 90 degrees. The blue lines, we have between them exactly 90 degrees. The green lines, we have between them exactly 90 degrees. And now we're gonna draw a shape between these points. From these points, we're gonna join these points. How come? According to this. If you want to write here A and write here A dash, it's okay. Red, you're gonna write B, B dash, C, C dash, and D, D dash. Then join them respectively according to the shape and write inside it R dash. Thank you for listening.